Okay, welcome to Unit 5. We're going to look at something called dimensional reduction in Unit 5, and in particular a method called principal component analysis, PCA. So why are we doing this? The main reason is that many machine learning problems involve huge data sets. We often, like this quote says, have thousands, even millions of features. So that's columns in our data, and this makes learning very difficult and often very slow. And so we often need a way to reduce this. An example is if you might have a data set of movie reviews. So every user in your system might review movies, and then so for a given movie, you might have reviews from 1,000, 10,000, 100,000 different users. So each user's review is a different feature here, and so your data set can get very large here, and often we need to reduce that in order to even process it. It just takes up too much space often, or too much time. So we're going to look at some options here. Now, I've selected 3 videos out here. One thing with principal component analysis is it can get quite technical and mathematical rather quickly. So you have some choices here. The first video probably is a good overview, but is light on the technical stuff. Whereas the third video, it really helps if you've had linear algebra, so Calc 1, Calc 2, and then linear algebra 4, to really understand this video. And then the second one here is kind of in between. It just uses some terms from math like orthogonal eigenvalue, but you can often understand this without having gone into depth on what those things are. So again, choose one of these videos at least to watch, and it should provide you a good overview of PCA as we begin. I also have an article down here on PCA that just, if you like to read, this just goes over and kind of a brief overview of PCA. Again, this gets kind of technical, so I would just focus on the first couple sections of this. So again, it talks about actually what we'll be using in Python, introduces principal analysis here, and it looks at like some data here. This is two-dimensional data, and it shows that with that two-dimensional data, we could look at it's mainly going on one area and possibly another area, but we could look at this one dimension and convert this two-dimensional data down to one dimension. And they talk a little bit about that, how this two-dimensional data can be converted into one-dimensional data, and see how that works. And they also talk about higher dimensional data. We'll be using this handwritten data set called MINST for this, and they talk about the same thing. So these are the digits 1 through 9 that are written out, and the data set's rather large. Not only can it have lots of pixels, also lots of features, but there's lots of example images. Here they look at an example with an 8 by 8 image. So that means there are 64 dimensions in our data. We're actually going to look at a larger version of this same data set with each, I think it's 24 by 24 pixels. So there's 784 dimensions in our data, and then we'll look at changing this. But this is just a quick view. This shows how PCA can be used to convert this 64 dimensional data down to 2 components, 2 dimensions here, and the different colors show the different digits here, and it does a fairly good job of grouping the digits together in a lot of ways, and so PCA can be very useful for that. Okay, so again, watch one of these videos, review the first couple sections of this article, and then we'll go on to the learning exercise here. And that will open up this, again, similar to before, you'll have this learning practice a notebook to keep, and there's section 0, which you always have to run, and then there's 3 main sections out here. The first section looks at PCA and iris data set. The second section looks at PCA with the breast cancer data set, and then the third section looks at this MINST digit, handwritten digit data set, and using PCA with that. And there will be videos in front at the start of each of these to introduce those. So hopefully you enjoy this section.